solar, wind, biomass, hydro, geothermal and ocean, we'll examine the key technologies, old and new, that are driving them forward, and the pivotal role that electricity will play in our energy future. There is an exciting, renewable, electric, peaceful, prosperous, safer future just up ahead. We just need a little more imagination to get there. Thankfully, imagination is renewable too. Chapter 1. There's no such thing as energy. It is important to realize that in physics today, we have no knowledge of what energy is. We do not have a picture that energy comes in little blobs of a definite amount. Richard Feynman, 1963. There is no such thing as energy. This might come as a bit of a shock. Einstein's famous equation, E equals mc squared, tells us that energy equals mass multiplied by the speed of light squared. So there must be such a thing. Energy, it turns out, is much slipperier than our everyday understanding suggests. We might think about paying our energy bills, investment in new energy technologies, and the wars that are fought over access to geographical blobs of oil and gas. But intellectually, the scientific idea of energy is mind-bogglingly abstract. If you were to ask a physicist, what is energy? They would probably explain it as something that exists in various forms and can be converted from one to another. They might discuss examples of these conversions before talking about a very important law of physics, that of the conservation of energy, which is the idea that the amount of energy within a defined boundary, or closed system, as physicists would say, remains the same. In other words, energy cannot be created or destroyed. Energy is a mysterious property that has intrigued and battled philosophers, mathematicians, and scientists for millennia. Variants of the word energy date back to the Greek energia, from en, meaning in, and ergon, meaning work. However, none of them were used in the sense of our modern-day scientific understanding of energy as the capacity or potential to do work. The history of exploring the physics of energy is rich in observations about the conversion of energy from one sort to another. What, in fact, is being conserved is only understood by uncovering the mathematics behind each of the forms of energy in a system. Today, we understand energy at its most fundamental level as mathematics. Before we had uncovered the laws of physics and their various mathematical expressions, as they relate to different forms of energy, we had some really fascinating and sometimes strange notions of the thing that is being conserved. Dead and living forces. Women are the largest untapped renewable energy source in the world. Neha Misra, co-founder of Solar Sister 2019. The law of the conservation of energy is held so dear today because it was so hard won. Our journey to the present modern understanding of the idea of energy has taken many interesting twists and turns. It's a 200-year detective story about what exactly is being conserved in a system. We've been scientifically curious about the idea of heat since ancient times. The idea that things contain heat and that this had something to do with the motion of things too small to see with the naked eye was being discussed by the English philosopher Francis Bacon as early as the 16th century. Bacon was one of the first to realize that heat had something to do with the motion of small things, though his observations that pepper, mustard, and wine are hot might have suggested he wasn't about to discover an important law of physics just yet. Known as the father of experimental philosophy, his reputedly one and only actual experiment involved stuffing a chicken with snow shortly before he caught a chill and died. Fire made us human, fossil fuels made us modern, but now we need a new fire that makes us safe, secure, healthy, and durable. Amory Lovins, 2013. Hot on his heels, the French philosopher René Descartes understood the world as comprising three types of matter with differing viscosities: liquid thicknesses, fire, air, and earth. The Dutch philosopher Christian Huygens observed that something he called calculatrix was conserved when objects collide. Not a character from Asterix, calculatrix is in fact a mathematical quantity related to our modern notion of kinetic energy. A huge step forward came when the notion of what is being conserved was linked to the concept of force. The German polymath Gottfried Leibniz explored a world of dynamics.